Well, we are both developers in the application team, so especially in the supply chain domain. And we are going to talk to you about how to make tests with the help of new infrastructure tools that we have in NAV 2013. So we'll break our session into the following two parts. We are going to talk about testing, the two approaches in testing, and then we go into the new tools that we have in 2013, the test isolation, debugger, and code coverage. Now, it's important to understand that unit testing is something that is not really a new tool, but it's a methodology, which is to say that it's a white box, low-level testing for small units, which can improve the confidence of everybody who is developing NAV to increase their confidence in code. Before we understand what unit testing is, we need to understand what a unit is. A unit typically is a very loaded word. CAL, being what it is rather limited in terms when you compare it with the new generation languages. However, in general, a unit would mean any encapsulation of a function, procedure, which encapsulates an implementation to which an input is passed, and that gives out an output. So depending on what the output is coming, one can see if the output was expected or not. And then one can make a test. So in this case, for example, if the output here was 64 or 66, it would have been wrong, and our test would have failed. And we would have successfully maintained the contract of the unit. So in CAL, we also have units which are functions or procedures or triggers. And in the context of CAL, the inputs become the parameters to a function, the state of the database right before the code is exercised, or even global states of objects. So that means the values of global variables inside a code unit, for example. The output would be return values of those functions, or the parameters which are passed as vars, or even error messages that pop out of the function, or the change state of a database. So you have different records or different fields in the record after the unit is exercised. Those could be your expected behavior. Now, you could ask whether you could test local functions this way. Yes, a local function can be tested this way. However, it is to be noted that the unit in such a case becomes the first public procedure which accesses the local function directly or indirectly. We have had a fair understanding of what a unit is. Maybe we could delve into what a unit testing would be. The objective of unit testing is to test the unit, of course, to test that the unit functions as we want it to. So it basically safeguards the implementation contract of a unit. Now, what does that mean? It means that if I change the code inside a unit, and the unit can be function or procedure, then my expected behavior would change. So it's often that the unit test is quite tied to the implementation. And so it's more failure prone as soon as you change the implementation. The parts of a unit test would be just like any other test, where you set up some data. And typically in a unit test in CAL, this is done by direct assignments, direct insertions of records into the table. In unit testing, we are not really bothered about how the data came to be generated. All we are bothered about is that the data is generated as it should before the unit is called, so that the unit produces our expected output. So then, after the setup, we execute the unit or the code under test, gather the results, and verify. There could be a need to have a teardown of so basically you make some setup before the unit, and the unit could change the database. Now, there could be tests which have an assumption of what the state would be. If that assumption is changed, so if the data, for example, let's say a record like general ledger setup or sales and receivable setup, one of my tests changes the sales and receivable setup, and it changes it to some value which was not the default state. And my second test expected the default state. The second test would fail without reason. This is the reason why we need a teardown in order to bring the database to the state before the test. It's to be understood that unit testing is best suited to small units, because as your tests bigger units, the amount of setup data required is also heavy. A unit, if big, there could be many code paths that one could traverse, and that could be complicated code paths. And to reach a certain point in your code, you might have to go through, traverse your way through many ifs and test fields and error messages before you reach your real lines of code that you want to test. This is why the setup can be complicated. So as long as units are small, they are rather quick, and this is a quick way of testing smaller units, lower-level code. So we would go into the demo straight away, and let me start with showing you some basics of CL test. So what we have here is the development environment for 2013. And I have made here something called a test code unit. So this is a test code unit. Why do I say that? Because the property of this code unit is test. This is a new property subtype. What it essentially means is that this test code unit will have many test methods. What is a test method? I have made some test method called demo1 unit test. And if we look at the globals and look at the properties of that test method, we have a function type called test. A test code unit has many test methods. When you run a test code unit, what happens is, instead of just running the on-run trigger, it actually runs all the test methods one after the other. In fact, we actually don't guarantee the sequence in which it is run. However, all the test methods in it are run, along with the on-run trigger. So what I have here is, I have created a simple method called demo1 unit test. So let's actually go back to one of the cases where we could make a unit test. So let's try to change costing method of an item. And this is typically the validate trigger in the item card, like here. So I have my item record. I go to design, and I have a field 21 costing method. And suppose what I want to do was test this line. It raises an error messages when reached. So I will have to go through all of this code in order to reach here. The unit, and just to give the relevance in terms of a use case or a walkthrough of the use case, I'll actually take you through it. So let us say we open an item, make a new item called test, and then we go straight to item tracking code, make a new item tracking code. Let's say test IT, and look, notice that the SN specific tracking is false. If that is the case, then, and we set this to item tracking, and in such a situation, if we try to change the costing method to say specific, it gives me an error message. And this is the error message that was triggered from the onValidate trigger. So in case the item tracking code .sn specific tracking was false, which means that item tracking code was not serial type. We had that error. So some parts of the application is perhaps clear to you. We can actually start writing our test now. The first thing to write is the exercise unit. So we exercise the unit. What is the unit? The unit is clearly the onValidate trigger, the costing method. So call validate trigger on item. That would be item dot validate costing method, and it triggers only when the costing method is specific. So now we have our unit quite clearly defined here. What happens when in case the test would run fine, this would raise an error. If the test was run, the error would be raised and the test would have failed. So we need somehow to catch the error, and that is done by the keyword assert error. This has been introduced typically for making possible. It's part of the testability framework. So what it does is catches the error, gets a handle to the error message, and keeps it so that it can be verified later. We have caught the error here. All we need to do is now verify it. So we need to verify the error message. So that is done by, what is the error message? Error message should have something called SN specific tracking must be yes. So the way we can code it is, now this is another infrastructure variable that we have, a system variable, which is the handle to the error message. So if we say that it has tracking this message, SN specific tracking, then we are through. But if it's not, if it does not have that, then we should fail the test. We fail the test by making another error. Perhaps a wrong error message. So the good part is we are halfway through the test already. We have done our exercise, we have done our verify. Now all we need to do with the setup. In order to call the validate trigger on the costing method of an item, we of course need an item. So one of the first things that we need to set up is create item. Notice that, of course, on a record, we'll always initialize it first, and then we set the primary key. Let's say test2. And then we say item dot item tracking code is equal to some IT code. Save it. At this point of time, we have written a part of the test. We will try to run it. Let me close this window first. Run it. Notice that it fails. Now, we can, in 2013, we can use the debugger, the details of which will be shown by Ellie. But for now, we just want to reach the point in code where it fails. So we start the debugger, and we run this once more. So it fails on item tracking code does not exist. It fails at this point, where it's trying to actually get, not only do I need to specify a code on the item tracking code field on the item record, but I also actually need to have a record in the database with that name. I'll just let this run through and fail the test completely. And then I go back to the client. And next, I need to make a item tracking record. Create item tracking code. So it's the similar thing. We call the init first. At this point of time, we fill in the primary keys. Test ID code, let's say. And we say insert. Now, the key thing here is that the SN-specific tracking field in the item tracking was false. So in order to make that clear, we can actually go to the symbol menu and say that field is false. You might argue that this is unnecessary because always the Boolean fields are defaulted to false. However, writing the statement here makes the intention of the test very clear. If we save this and we run, oh yeah, of course. Sorry, I forgot a step. Let me make this fail. I need to make sure that my item tracking code actually is what I set it out to be. So, and we run it once again. Note that it fails. Oh, does it? No, it doesn't. Because it actually goes and raises the error what we want it to. And our assert error catches it. So if we just say continue, the test actually passes. Making this test pass, essentially what we have done is we have created some setup, ran the executed the unit, verified the error message. What about teardown? Now, that's a step we are missing here. Notice, if for those who have used CAL coding, that when an error happens in the code, all of the database transactions till the point the error has happened, unless you have made a commit, gets rolled back. Therefore, although we have created so much data, maybe it's not so much, but whatever data we have created, it gets rolled back anyway. So there is essentially, it gets rolled back because there's an error coming from here. So there is nothing to tear down, so to say. So that's our test. We have written our first test. Now this was a simple unit. Let's actually take a little more complicated scenario. So my second case is a little functional in nature. I post a sales order and verify that the posted shipment line quantity is the same as the quantity on the original sales line. Let me walk you through this. So again, let me make an item. This time I call it test3. And I fill in a base unit of measure. I fill in some posting groups. And then I try to make a sales order. Test3. Let's say I want to have a sales order of 7 pieces, and then I post it. Notice when I click the action post, there comes a string menu, and I choose ship and invoice. What happens here in the back end? Of course, a posted shipment line is created. If I just go to the last one, open it, I have my a copy of the record of the sales line with quantity 7 pieces. Now, I just happen to know Not because I'm a developer in NAV, but because I'm writing a unit test. Since the unit test is tied to the implementation, I need to know what my unit would be. In this case, the unit was the posting function. And the post happens in code unit 80, if you know. In fact, I would show you. So sales post is my unit. Sales post on run is my unit. It's a, for those familiar with this code unit, it's a rather large code unit doing a lot of stuff. So I have purposefully taken an example of a big code unit. Let's see what happens if I have a big unit like this. And we'll start making our test. Meanwhile, I'll close these windows. And I have gone a little ahead of myself and created this function already, just to save time. So notice our exercise is sales post, code unit 80, which we need to pass a parameter, that's the sales header. And then we verify the shipment lines has the quantity as 7, which I set here, I set on the sales line, and I verify the same quantity here on the posted sales shipment line. Once that is done, I make the setup, which is essentially create the item, create a sales header, create a sales line. I would like to draw your attention to the fact that notice that all of these are assignments. We don't call, say, sales line.validate item, because we don't want to run through unnecessary code that the test unit does not, the unit on the test does not require. We mock the data this way. So we have made a test. I'll make this function as a test method. So that's demo2 unit test. Function type test. And just for simplicity's sake, I would actually set the first function as a normal method so that it does not run when we run the test method. Notice also that I have a teardown step. When I create this item, and since I'm not expecting an error happening in this scenario, all of my setup will get committed to the database. If, for example, my next test tries to create the same item with the same name, it will fail. It will fail because the item is already there in the database. Therefore, we need a teardown. The teardown is rather simple here. I have it, I don't know if it's visible, but I'll try to. So this is the teardown, and the code in it is essentially deleting everything related to that item number. So let's run this. I have close my debugger, and this is my test. Run it. Actually fails. Now, I'm showing you these tests because typically this is the way one writes a unit test. So we turn on the debugger again, and run it once more to see where it fails. It fails on a test field record, sell to customer number. In order to finish the scenario, I have to actually go through all of these test fields. Sell to customer number, bill to customer number, posting date, document date. I need to fill these in the sales header. So let me actually do it. Let me make this fail and go back to the code and fill in all of those things. Maybe I should use the symbol menu because it's faster. Sell to customer number, bill to customer number, document date, and posting date. say I use workdate. I just need to pass that line which makes the test date, so it's not important what value I put in this case. And here I would just use an existing customer. I have the demo database here, so 10,000 is an existing customer. In fact, I will go ahead and also set due date because I know it will also fail there. So now let's try it again. It goes a little further. It didn't fail here. But nevertheless, it fails in some other place. It fails because ship field on sales header is false. Now, I'll make this fail. And notice that as I proceed through a unit test, I'll find errors along the way. And I have to, for example, in this case, put values in those fields so that it goes forward and it finishes my scenario. And for that, initially, I never thought these lines were important. So I will just try to distinguish them by making stars as comments. I mean, I can get through this by, say, sales header.ship equals true. But I know for sure that when I run this test, there will be some other variables that I need to be set. So what I've done is I've actually created this code unit, which has exactly the same examples that I showed you, but I think it works. And notice the amount of starred code that I need in order to make this unit function. It's a lot, isn't it? You can see it's almost all green here. Of course, I have the same teardown as I used. So, but it has not, even if I had passed through ship is true, all of this, I would still have to set a lot many more things. But nevertheless, we have done our test, and if we run this one, so I'll stop the debugger. If we just run this one, which does essentially the same thing, it was successful. So what we have demonstrated here is that we have a unit test and how to write a unit test, what are the problems creating a unit test, but however, as long as the unit is small, it's easy to make tests for it. It's important that you notice there in the sales line, there is a key called line number, but I'm not setting it here on purpose. What I want to show you here is that it's not important to even set primary keys all the time, because essentially you don't want to have full-fledged complete records. All you need to do is mock up the data so that the unit can exercise it. Now, it's because that we are not making complete data that there could be corrupted data in the database, which was only created to make our unit run. It's because we are making corrupted data that we sometimes need to explain the intention of what the test should do. That's why the comments are very, very useful, especially in the case of unit test. So we have seen the first unit test, and I think I will let Ellie take over. Where he speaks about...
Hello. Can you hear me at the back? Good. Thank you. Thank you very much, Data, for giving us an intro on unit testing.
I think we need to start.
We got. I will talk not about unit testing, but I'll talk about a new feature called page testability. You might have heard an intro already about it. Oh, what happened here? Just a second.
I think it was still out of battery, so it switched off. So sorry about that.
But Data introduced us to the concept of unit testing. There were several themes in his unit test introduction that appeared, you might have observed. when he, for example, wrote the tests, he actually declared tables and code unit in order to invoke functionality. Now, doing that became a little more unnatural to what the program is how the program is actually accessed by the user. Typically, for a user, he would go to a page and perform actions on it, enter data and perform actions on it, or he would go and run a report. And that approach becomes slightly white boxing, that you need to know a lot about how the application behaves when you do an action, so that you declare these variables that invoke that functionality. So in Dynamics NAV 2013, a new feature was introduced called page testability that wanted to achieve two things. First, to be able to access the functionality the same way the user does when you're writing a test. And secondly, also achieve high code coverage, because some of the code actually resides in the page objects. And prior to this release, it was impossible to access that code programmatically. It could only be run by the user. So we missed some parts that could be tested. I'll just log onto my machine, if I can remember the password. It's so difficult, even I can't remember. So where were we? So yes, this new feature called page testability now allows a developer to write a test using it, which actually can do almost all the actions that a user does when he accesses the program. So it can open a page, it can enter data into the fields or controls that you've added on the page, just as a user would do. And then it can invoke the actions that have been implemented on that page. I'll try and do a demo for you and then walk through some of the features that have been added to enable this feature. So the demo will be about, very similar to what Data had already done with unit testing. It will create an order for an item, enter a quantity, and post the item, and do verification since it is a test. Data will come back to it and compare the two approaches. Can it switch? It switched. Oh, thank you. So I'll first open the test code unit that has implemented this scenario. Down here. And I'll scroll a little further down. And this is the code. I'll also go to the application, and I'll open the sales order as it looks like today. I'll just open it in new mode because I'll create a new sales order. So this is how the user actually interacts with the program. When he's actually going to the sales order, he sees different parts. There's this part here, where he enters the information about the customer. It's just a part. And then there is another special part here where he can enter information on a grid. Then there are fact boxes on the side. And then right at the top, there are actions he can invoke during or after his data entry. Let's go back to the test. And then I'll go to the test, and I will show you the variables that I declared. So if I go to locals, you will see here that There are several variables I've declared. The first three have a data type called test page, which is the new type that supports page testability. When you do use this one, you need to point to a page that you have defined. So you don't need to declare a new type for the page you want to test. So here I'm pointing to the item card because I'll need to create a new item. Put in the sales order page, just like the one the user sees. And then there is also a posted sales shipment. Now, what does it mean when you use this test page? I'll move over to the test. Out here, you can see the item card page variable first invokes an open new. Never mind about this line because it's just a normal variable that stores the name of the item because it will be used later. And then it calls set value, assigning that value it's set up here. And then it calls another set of set values. And then it says OK invoke. Meaning here, it will open the card as though the customer would, a user would open it in new mode, enter a set of values into fields that are necessary for that item to be used. So these three. And then it will hit the OK button with this new command here. And then it will move over to the sales order itself. So now I'll go to the symbol menu again. And I'll go to that sales order test page. And you can see, when I go into it, I can see a list of groupings here. And on the far right, there are a list of functions, which are standard functions. So these are the type of operations you can do now on that type that has been introduced. So you can do almost all the user actions that can be done by a user. For example, you can open the card in new mode. That's true. Edit mode, you can open it in view mode. You can close it again. You can say new so that it creates a new record, and so on and so forth. And you can even traverse back and forth. You can go to the next record, the previous record. You can go to a specific record. And there are properties as well. So for example, here, the easiest property to explain is caption. You can read the value of the caption on the sales order, which is usually at the top. And you can also read what the filter is that the user has set or the program you're writing has set. Here on fields, you can see all the fields that are attached to that card. And then you can go to the parts. This is a bit interesting. So here, I'll go back to the fields first. So on a field in Navision, when you're working on a field, you can actually do a certain set of actions. So now I'll just indent further and see what actions I can actually invoke also in the program. So you can actually do a lookup on that field. You can do a systedit, drill downs, assert, and validate what value that field has. You can set a value, which is what we are doing a lot in this test. We are setting values using this. You can invoke, you can activate, you can even check what type it is. And you can even check on the state of that field. Is it editable? Is it visible? I'll go back again. Then there's the parts of the page. So you can even access the parts of the page. So on the sales order, in fact, there was several parts. This lines here is another page that is added to the sales order. So it is a part. And the fact boxes here are parts. So you can even access those parts, identify further, and perform actions on them. And that's what I'll also do because I need to create a new item onto that sales line. To add the line item to the sales line, sorry. Then there are actions. So these are equivalent to, if I go back to the order again, to what is implemented here at the top. So I can access those actions. You might notice that some of them have funny names on them, and that is because you have to do a little bit more to make it more readable. You need to go to the, when you add an action, you can actually add a name. So what you're seeing as a user is the caption. To the program, you would need to see the name of that action, which is two different things. So here are some of them. Somebody has done us a favor and given them human names. The others, a little too bad. And then there are built-in actions which you don't normally add there by default. Those are the OK buttons at the bottom. These ones you get for free. And you can also invoke them in the code of the test. And this is what's happening here. I open a new sales test page, sales order in a test mode. I add a value to the sell to customer 10,000, if you probably know that customer a lot. I store the state of the order number because I'll use it later during verification. I go to the sales line, I create a new line. I set the type to item, and then I set the item number that I created here. I put in a quantity so that it can post. And then I go and invoke an action on the card, which is post. And once that's done, I go to the verification. And the verification here is I go to the posted sales shipment that is created after the posting. I open it again in the card as a card. I filter, just as the user's possibilities are. I filter for an order that is related to that shipment. I go to the lines of that sales shipment, the last line, and I check, using this assert equals, that the quantity on the sales shipment line is the same as the order that I had. And that's the test. Later on, I tear down. I just destroy the data that I created. So let's run this test and see what happens. To do that, I'll use the debugger. I'll go to the page, because that's the interesting part, the sales order page itself. And I'll go to actions for that page, and I'll look for the post action, because I know I'll call the post very much later on. It's this one here. I'll view the code, and I'll add a breakpoint. So that when I run the test, I'll check whether the code is executed on a trigger that is on the page. So now I'll turn the debugger on. And then I'll go and run the test, which is implemented in code unit 63702. So I run it, and the debugger breaks. And I can see, looking at it, that it broke on the line that I set a breakpoint on, which is on the page. That was impossible to access through code prior to this release. And I can see, looking at the call stack, that that code was hit through my test. So it actually passes until this step. I'll complete the running of this code, and the test code unit says it actually passed with the verification check. So what have we seen here? So now it seems like in 2013, it is now possible to implement a test that looks very natural without knowing too much of the internals about code units and tables. You can just focus on the page and just invoke actions just like a normal user would do it. Thank you very much.
Thanks, Ali. We would just bring up the PPT again. So we have seen some basics of how to make a unit test and page test. It's time to step back and think about which approach should one take. There are various reasons, and I'll come to them as we compare the two. But for now, I would take the same code unit that Ellie was using and show you, compare the two tests. I'll just close the debugger. And so this is my unit test, and this is my page test. They do the same thing in a slightly different way. So I keep them side by side. Notice that there is a page test also for the first demo that I showed you. Notice that in a page test, I use the test page type a lot, whereas in a unit test, I use direct manipulation of the record. One more thing that is to be seen in a page test is that I have a handle string menu. For those who are new to testability, this is something to handle, for example, if I have a sales order, and if I make the post action, just like we did, it's the string menu that I'm referring to. This is a modal form, which does not allow you to access anything else. And this is why it's important that the program has a handle to it and able to ship, invoice, or select one of the choices here. I'm selecting, of course, the sales and ship and invoice choice here. So I use the handler for this test method called demo2 page test. So if we see the properties of demo2 page test, go to the globals, demo2 page test. Notice that the handler has the same name as the function in which I have coded the handler, which is demo2 page test handle sales post string menu. So now, before we get into the comparison of the unit test and page test, I would like to show you something else, which is a new kind of code unit, yet another new kind of code unit, which has a property not of test, but a test runner. What we had seen was we were making code units of this type. Now, test runner is rather useful in the sense it can be used for running many test methods, like if you want to make a regression test batch suite, then you invoke the test runner. And you can see that I'm running two tests already, the two tests being unit test and page test here. And I'm getting the result of the run, and also the time it takes for the run, using these methods that you would need to define in a test runner method, on before test run and on after test run. In on before test run, I set a timer, and this is typically called before a test method is invoked. On after test run, of course, is the method that is invoked right after the system has completed execution of the test method. And at this point, I reset, I get the time taken, the duration, and I show it up. Let us see what happens if I run the test runner. But before that, I must make sure that both the test methods in my page test code unit are of type test. And that's how I do it. And this one is already test. Save it and run. Note that, of course, they were all successful, thankfully. But the time difference. In the unit test, both of these are unit tests, the time taken was significantly lesser than the page test. However, so at least one of the criteria is the speed. Now, page tests are fast. Of course, they are much faster than what would happen if the user had to go through clicking all pages, all the actions. Page test is fast, and in fact, it helps you to reproduce the problem much quicker. In fact, I do hope that after this session, you would probably, in addition to reporting bugs in repro steps, you might as well send us a page test doing the same thing. But so page test is useful in the sense it helps you mimic the user experience. But unit test is faster because it executes much lesser amount of code. For example, it doesn't call the validate triggers, which is often the case with page tests. Then comes ease of scripting. Unit tests, as long as they are small and they are fast to execute, they test small layers of code. So it's easy to understand the unit test. But as a unit test becomes large, as the unit becomes large, the amount of setup data that is required is also very large. And that makes bulky tests. So one must be aware of that con in a unit test. However, ease of reading and ease of scripting in a page test, as we saw, was because it kind of mimics the user experience. So whatever the user does, we have a code line for that. So it's very easy to understand a page test. Because of the complexity involved with large units, unit tests may have starred code. The starred code, of course, I'm referring to the comment where I thought I would never need this line, but I had to add it in order to pass that line so that I can finish the execution of my unit. So the smaller the unit, the less number of the starred code, the easier it is to maintain. But in a page test, it's completely implementation agnostic. So in a refactoring project, you might completely change the code, but as long as your functional behavior is what it was, your test will pass. So both serve different purposes, and one needs balance to think about which approach one chooses. In a general environment, we recommend that you write as many tests as possible as unit tests, testing small pieces of code, but many in number. So you test all your code in small chunks. Once you have built confidence using that approach, you can create less number of page tests, which are higher level tests, to do system tests or manual tests also. So as we go up the triangle, the number of tests reduces. Let me show you a new property in 2013 called test isolation. For that, we refer back to our test runner. Before that, perhaps I should talk about, it's a new property of test runner, and it eliminates the need for writing the teardown step. Wouldn't it be wonderful that you write a test, and no matter what data it creates, it is runnable again and again using the same data that it creates in the test? For example, in my unit test, by second unit test, I use my item. And so if I run it twice and I did not have the teardown, notice what will happen. So what I do is I go down and comment out the teardown step. Save it. And I do also for the page test. So I go down, comment out the teardown step. And then I run my test runner, which runs both of them in a batch. Notice that the page test failed because the second demo2 unit test created the item with the same name, and so the page test failed because it could not recreate this item with the same name as it exists in the database. So that is a problem sometimes when you're batch running the test. So what I would do is I would go into the test runner and set a new property called test isolation to code unit. So what this means is all the test methods in a code unit would be run under one transaction context, and the data created in all the test methods will be rolled back after the end of the code unit. We also have the possibility to have test isolation of method, which basically means the same, but the transaction context happens in the test method. Data is rolled back after the test method is completed execution. We set it to code unit, and then we go back to the test. Now, of course, these tests would fail because something called my item is already there. So I'll just rename all of them to something else. But all of them use the same item. And my test isolation is code unit. So let me run this again. And this time, they pass. So item is created, but because of test isolation, it's rolled back. So I'm always back to the start of, I'm always back in the database to the state where it was before this test started. So to summarize, test isolation is a great property to be used when you use batch running of tests, and it helps in regression testing. Over to Ellie for something rather exciting.
Thank you, Data. So that was all about testing and all the new features that have been introduced. I encourage you to go try them out. They're really nice. We move on to something completely different, but very related to testing. That's the debugger. So if you haven't been writing tests on the code that you implement, I think you'll need a lot of help with debugging the bugs that you introduce. So the debugger has always existed in the program. The only change that's happened is, one of the big changes that happened is that the classic client went away. In 2009, there was no support for the debugger for the RTC client. In 2013, the RTC client gets the debugger, and actually a new debugger, which covers all the features that were there in the old releases and adds more to it. And it's not only the RTC client that benefits, it's all the types of clients that are in 2013. So you have the web client, you have SharePoint client, background sessions, NAS, all of them get support from the debugger when AL code is being executed. The other thing about the debugger is the debugging experience itself. So for 2013, the debugging experience has been extended to improve the discoverability and troubleshooting of bugs that might appear in the program. And this includes stack trace, return values, cutting out the noise that you incur when you're debugging. I'll go through a scenario that helps explain all the features that have been introduced. And the demo will be about entering a sales line. Only that. Can you switch? Oh, I didn't see that. So what I'll do is that first, I'll go to a code unit called Sales Price Calculation Management and introduce a bug. This functionality is accessed when you're entering a sales line to calculate the price that should be assigned to the item that you're selling. So I'll go to a function called calculate best unit price. I'll go to the definition of that function. There it is, and change the code a bit. I'll change this line. And instead, I'll write while find set do. This should introduce an infinite loop when this functionality is invoked. I'm very bold to do that, but I can afford to do that in 2013. Don't try that on older versions. You'll need the task manager. After that, I'll go to the functionality. I'll also turn off the debugger completely. So I'm assuming that I'm clean. I have no debugger support yet. And I'll create a new sales order. Enter the header. Go to the line. And enter an item that exists, 70,000. the program is not responding. It's probably hit that code now. So now I'm in an infinite loop. The only help I can get now to get out of this problem is probably the debugger. So I'll go to Tools, and the debugger is where it's located today in older versions. It's in the classic client. It's under this menu. A few things have changed out of this menu. And the menu item that now appears, it says debug session. That's very different from the old menus. So it's cleaned up a bit there. And when I click on that, as I've clicked several times, and Data has as well, a session list appears. This is different. But the session list becomes powerful. It becomes the access point to all the different types of clients that are currently running that service. So in this instance, the only session I see is a Windows client session, which is the RTC. But if there was a web client, you would see a line as well here. If there was a SharePoint client, you would see another line here. And you can connect to any of the sessions that are currently running. So I'll try and connect to the session that I'm on, which is having a problem. So I'll just hit debug on that line and break. And I've entered the piece of code that is being executed. And I noticed the line that I changed, so it's definitely here. And now I've arrived to where the problem is. It's pretty narrowed down. I can step over, and I can see that I'm not going anywhere outside this loop. So now I've narrowed the problem. I can actually go down and figure out what the problem is. That's pretty powerful that I could actually get to an infinite loop. What is also interesting while I'm at the infinite loop is that I can go and traverse the call stack itself. And that was possible in the old versions. You could go around the call stack and see what functionality called what. But what's interesting here now is that now, even on the bottom call stacks, I can actually access the values of the variables. And that gives me a clear opportunity to see what is the repro scenario that I have to reproduce this problem. In the older versions, you could not see the values that caused the problem. So that's the other neat feature, that you can inspect the values. Another debugging experience that has been improved. So I'll go back to the problem here. The problem is still looping. It's broken at this line. Is that you can set breakpoints. That's old news. Which part did I want to talk about first? Yes. This line of code here has a call to a function, actually two calls to the same function. But since it is in an expression, in a condition loop, it's difficult to tell what the first call's result will be as opposed to the second call. In 2013, I can step into the call, the function itself, and check what value it will return. Now, you notice in this function here, it actually can return in 2 points. But never mind. If you want to check the return value, all you need to do is set a breakpoint at the last line. I'll do that. And I wouldn't care which path it actually exits. And I'll run it. It goes to the last line. I'll then go to the variables. And there is a line here called return value. I'll just add it to the watch. And it will appear here on the right side. So now I can see that the first call returns 10. It will enter the function again with the second part, and I can check what value that will return, and I can compare the two for my debugging experience. Go to the end. It also returns 10. So now I know what behavior it is doing. So that's the other feature. Another feature is conditional breakpoints. Notice also in the same piece of code, there is a loop. And loops are really difficult to debug if the loop is too long. For example, you're looping where the set is so large, you might be interested in a few of the records. But it's difficult to do so in the old client. What you would have had to do is probably stop the debugger, go back to the code, like this looping code, and add a condition and set a breakpoint there and wait until it hits that code. And that was a little too tedious. But here, you can actually set a condition itself. So what I'll do is I'll add to the watch the variable that I'm iterating with, which is the sales price variable. So I'll go here and add one of the interesting fields, the minimum quantity, and put it out here and set a breakpoint here. And continue. And I see it hits the breakpoint with the value 10. The next time it does, the value is 20. The next time it does, it's the value 0. So I might want to narrow my inspection, and you can imagine that the set could have been larger, to only quantities that are above 10, or at least 10. For that, I can go to the break rules. Oh, sorry. Set condition. And I can enter the expression here. So I'll say sales price dot minimum quantity is greater than or equal to 10. Say OK. And then let's see what happens now. It stops when the value is 10. Remember, the values were 0, 10, and 20. 10 and 20. It stops when the value is 20. Stops again when the value is 10, 20. So it avoids stopping on the other values that were there. So that's another feature. Also, a little about breakpoints. There is another feature here that can list all the breakpoints you set. And the advantage of this feature now is that once you've had all breakpoints scattered all over the place, it becomes a bad experience to maintain them. So suddenly when you're inspecting another scenario, breakpoints just appear that you don't need anymore. And with this list here, it becomes easy to manage them. So even now I have 2 breakpoints. I could actually go ahead and say, disable them both. What it does is uncheck this column here. And so when I'm doing the next debugging, the breakpoints do not come up, even though they are still stored in the database. And I can decide to activate them whenever I think is necessary. So enable all, disable all. I'll disable them all now. So that's another feature that's there. I'll stop this scenario. And I'll show you one last scenario for another last feature. So stop it, stop. Thank you. I'll go fix that code, otherwise we'll have headaches here. I'll put back the original code and remove this disaster here. So now we're good. I'll now go to the sales line. And I'll move code a bit. So I'll take this line here, which is the availability check. When you're entering a sales line, you might have seen it. Some of you might have seen it quite a lot, that when you're trying to sell something you do not have in stock, an availability warning pops up. And I'll move it further down. And then I'll just comment out the code that does the price calculation. It's not so relevant for now. Good. Then I'll go and turn on the availability check. That tells me it's off. It's called stockout warning. It's back on again. I'll create a new sales order. Enter an item, 70,000 once again. And on a fact box here, we can see that the availability of this item is 2,202. Quite a lot, actually. So I'll request for 3,000 in order to provoke that availability warning. 3,000. And there, whoops, an error. And this is one of the system errors that occurs. You've probably seen it if you've been an AL developer. This error says to, hopefully not to the user, but to the developer, that his code doesn't work. What has happened to the database is that there is a function that has written to the database a transaction that has not been committed to the database. And it's not allowed in Navision to open a form if a transaction has not been committed. You have to commit it first. Okay. Now the problem comes in the old versions is how to find out what has been written to the database when. It's easy to see the form execution, that this is where the form is being called, but where did the record get inserted, modified, or deleted from the database? And this can be easily done with the new debugger. And I'll show you how that can be done because of this feature. This feature is not implemented specifically for this scenario, but I'm just highlighting this example. So I'll go to the debugger, turn it on again, debug. And then on the top here, there is something called break rules. And as you can see, there are 3 conditions for the debugger to break. The break and error condition has always existed. So you could say that whenever an error occurs, please turn on the debugger and show me where that error is occurring. That's a cool feature. But the last two have been introduced in 7.0. The last one, which I'll not demo, but I'll explain, is skip code unit 1, please. Code unit 1 is very noisy because it is invoked by almost everything that the application does. So in order to read the caption of what's on a page, it invokes code unit 1. In order to read dimension caption, code unit 1 is invoked again. And it became very annoying for the debugging experience of a developer. So the default setup is please skip these calls to code unit 1. So that's a nice feature. The other feature is break on any record change. So if you turn this on, the debugger will break every time something is written to the database. So modification, insert, delete. You can easily inspect, for example, code unit 80 and what happens by turning this on and seeing where it breaks. So I'll turn it on now, say OK. And then I'll go back to my scenario. I'll tell the debugger to break whenever it can. Go back to the scenario. And now it will break. Continue. Now it's having a jolly good time breaking everywhere. I want to get control of the, so this is the fun stuff like the CodeUnit 1 experience I just talked about. I'll just turn it off again here. Continue. Stop. Okay. So I'm on the control. I'll tell the debugger to break whenever it can. I'm not getting. Set the break rules. Skip CodeUnit 1. Break on changes. There, thank God. Okay. Now I'll set the quantity to more than what I have available. 3,000? I'll put even more. Thanks. And turn it on. So now I'm in the quantity on validate trigger. That's where I entered the quantity. So it has entered there. And I can see that we all know I moved the code here. And I know the form will be opened by this function call. But now I just want to see where the first insertion is happening to the database that might cause this problem to occur. So here I can see the first delete all that is happening. But by reading the name of the variable, it tells me it's a temporary table. So that's fine. That shouldn't be a problem. I'll continue further. I can see another temp record. Maybe that's fine. And right here, I see an actual insertion happening to the database using a reservation entry table. So now it has helped me narrow down the search of where a problem might occur if I move the code around, which was very difficult to discover using the old versions. So there we go. These are all the features that have been introduced that help you troubleshoot. You might find other scenarios where these features may be interesting, but I think it's a very exciting release for the debugger. And one other thing about the debugger, it's implemented as a page, so it is exposed to the app developer as well, so you can also go in and change it yourself. Please make sure it still works, though. Thank you. That's it.
It's okay. Thanks, Ali. I hope you're having fun there. Well, now I'm going to talk about something also which was present before and has been modified and improved, code coverage. What is code coverage? Code coverage is a metric to find out whether your given line, whether a given line of code is touched or not by some user action. So the usefulness in context of testing of a code coverage can be explained by these two questions. First is, so given that I am running my test using the code, turning on the code coverage, I can find out which lines of code are not touched. Why is that important? A high code coverage doesn't necessarily mean that you are verifying each and every line of code, but you're at least touching it. But a low code coverage gives you an indication that there are large chunks of code that none of your tests touch. Now, that could be an indication which you can use to make tests for such lines. The question can be turned around to find out that given this line of code, I want to find out how many tests touch it. That's also important information to run specific tests for a change that you make. not the entire suite. It saves you time. So let's go to the demo. Open the object designer. So what I have done here is I've made a code unit, a simple code unit, of which I'm starting the code coverage tool using this command. This is a new command in 2013. With a parameter true, it starts the code coverage and starts the logging of the code coverage lines. And with this, which has a command with the same function but having a parameter false, it stops the code coverage. And in the middle of them lies whatever code I want to execute. Now, this can be a test code. This can be some user scenario that you want to do and find out which code lines are hit when you do a user scenario. And finally, in this function, I just show the results. The way to show the results is, now there is a new prop table, system table, called code coverage. This is a virtual table to which all the lines that are touched or not touched are logged. And you can query that table just like any other table in CAL to find out information like this. Let me open the symbol menu and go to the code coverage. You can have the object type, which is the type of the object the touched line belongs to. Of course, the ID of the object. The line number relative to the first line in that function. The line type, which I'll explain later. The code line itself, and how many times it was hit. So coming back to what we were doing, I have some sample code of which I want to find out the code coverage of. If we just look at the sample code unit here, is this one. Very simple code unit, of which it can be noticed that the third line will never be touched because of the false condition preceding it. So we would expect this line not to be touched, but these two lines to be touched. So if I run my code coverage calculator, so if this line was touched once, this line was touched once, but this line was touched never. That's what we would expect. So let me just show you a customized view of the code coverage table. This is a page that I've just created in which there are the following actions. I start the code coverage, I stop the code coverage. I've already covered them. But there is something called refresh data. Calling this function is a new system function also, refreshes the code coverage log. So suppose you have started code coverage, and then you ran some code, and then you saw the code coverage log. And then you went again and ran some more code. You want to update the code coverage log. Then you use this function. Now we have run the code coverage already on that function. Let's see what kind of lines come up. So my page looks like this. I have just dumped all the fields in that table called code coverage, and you can see that the object type, object ID is filled in. The line type is either object, which is the start of an object, whether it's a trigger or function, and then actually the code lines, which could be very interesting. There is also a line type of empty, which is something like lines which actually don't do anything, like with statements or begin or end, repeat statements like that. Now what I'll do is just clear the data. Here I'm just calling delete all on the code coverage record. We start the code coverage. We go to our sample code unit, run it, and then say refresh data. So we get that this line had been touched once, this line had been touched once, this line never. And then we go back and we run it again, and we refresh it again. So number of hits is updated. This is useful in sense you can keep your code coverage running, do your scenarios, and find out how many times it was run. That kind of brings us back to the slide, and we're almost done. I'm sorry for taking so much time, but We have been doing a lot of talking. I think we are open to questions now. By the way, I do want to mention this, that using these testing tools and the new framework infrastructure that you saw, we have managed to have much greater confidence in the code that we write. I hope you would have the same experience. So. There is talk about that. We have not. Sorry. I was being asked whether we would release the unit test that we have made ourselves to test our own application. A decision on that is pending. I cannot answer that right now, but we are thinking about it, yes.
Can you go to the code?
Yes, I'll go to the code. What I've been asked, and that's a very keen observer here. What happens is, yes, I'll repeat the question, but I'll give the context of the question. Now, what the question was, when I happen to have a sales order open, here it is. So I have an availability of 3. And if I try to make it 6, it comes up.
I've already broken it.
No. It just needs to be reopened. Say 6. What's the availability? Well, the question was, as you saw in the last demo, actually, there was an availability warning that was coming up. The question was, when I was making the page test, why did the availability option did not come up, which is why I never ran. Which is why I never needed to have a handler for it. The reason was simple. I had switched off the stockout warning. Then I would need it. If I had switched it on, then I would have needed to have a handler to handle that availability window. That's right. You can specify more than one handlers, but what you're limited is right now, if you have 2 messages that pop up, for example, you would still have one message handler for it and have both the message in it. The handlers, there can be multiple handlers, but you have to have different types of handlers in each handler function. So one handler with 500 string menus, one handler for 2 messages, something like that. But that was a good question.
Yes, there's been a lot of discussion. Yeah, that's a good question. It's because you're saying that. Did you hear the question?
No, just repeat it.
Yeah. The question was, now we have this framework for writing tests using the new test page functionality. Isn't it a step closer to actually recording a scenario and having the test auto-generate? Is that your question? Yeah. Yes, and there has been discussions on it, but no real action on that subject. But no, not really. It's because for this release, the focus was mainly to get this feature done and to make it as useful as possible so that we can actually use it. So I don't know if it's what's going to happen in the new release, but it's a good feature to have. That's for sure.